Okay, the following is a video over Section 2, Unit 1, Section 2 notes, and this is Algebra 1, and this is about writing and solving equations in two variables. So our objectives today, we want to solve for an unknown quantity in a two-variable linear equation given one of the values. So you'll always be given one of the values, all right? Determine a two-variable linear equation that represents a scenario, identifying constraints and the variables in terms of context. So here's kind of a little, portion of your, homework or some strategies to help you with your homework. And it's this part right here, okay? Solving a problem with a two-variable equation. First thing we want to do is identify the two unknown quantities, okay? So identify what the variables are. Second thing, we want to write an equation that relates the two unknowns. Okay, and then we want to substitute a known value into the equation and solve. All right, so, just an example of a one-variable equation. The perimeter of the rectangle is 48 feet. The length is triple the width. So this equation models this situation, all right, and we have one variable. Okay, so one variable. All right. Now, if we re-say that, if we don't give this portion here that says the length is triple the width, then we have this other thing, this two-variable equation that says the perimeter of the rectangle is 48 feet. So the formula for that would be 2 times the length plus 2 times the width. So we have two variables. Okay, two different variables. All right, and so we're going to be working on two-variable equations today. And so let's go ahead and take a look at this example here, all right? And so it says that, and a lot of these are going to be word problems, so they are kind of tricky. I do want to make sure we understand what we're doing here. And so we have this problem that says Miranda has 55 feet of fencing. She wants to use all of the fencing to create a rectangular garden. So we have this equation for perimeter. So if I take 2 times the length plus 2 times the width of a rectangle, then we get a total of 55 feet, which is our perimeter, okay? Where L is the length of the garden and W is the width, can be used to find the length and width of the garden. Let me draw a picture of this real quick. I want you guys to draw a picture as well, okay? So I'm just going to draw a rectangle here, okay? And we're going to call this length here my length. So then over here, this is also a length. This length here would be a width. Therefore, this would also be a width. Okay? So with these two widths, that's where we get the 2W. Okay? Get the two L's, that's where I get the 2L. All right, so when I have that, I add all of those up, I should get 55. Okay, so I'm going to rewrite my formula down here, my equation. I've got 2 times L plus 2 times W, and that's going to give me 55. Okay, and so it says if Miranda makes the garden 17.5 feet long, how wide should she make it? So we know that L is equal to 17.5. So what I'm going to do is I'm going to take this value, I'm going to substitute it in for L into my equation, okay? So I'm going to rewrite this as 2 times L, except for I don't want to write L. I'm going to write the number that L is equal to. L is equal to 17.5. So I'm going to come in here, parentheses 17.5, okay, and then plus 2 times W is equal to 55. Now, what's unique about that and what I want you guys to see is that this was a two-variable equation. This is now one variable because I substituted 17.5 in for L. Yes? Question? Okay. All right, so then 2 times 17.5, that gives me, what is that, 35? So we get 35 plus 2 times W is equal to 55. Okay, and I just want to solve that for W now, okay? So I'm going to subtract both sides by 35 and solve this equation. Okay, I'm going to move this over here. Okay? So I'm going to get 2w, and then 55 minus 35 is equal to what, 20? So if I divide by 2 and divide by 2, then w is going to equal 10. Okay, so my width, and what was it, 10 feet? Okay. So our answer, we know that L is equal to 17.5 feet, and we know that W is equal to 10 feet. Okay, now if we really wanted to check this, we could plug these answers back into our original equation of 2L plus 2W is equal to 55. Okay, so if I plug in 2 times L, which is 17.5, plus 2 times W, which is 10, then that should give me 55, and it should check out. So 2 times 17.5 gives me 35, and then plus 2 times 10, which gives me 20, should give me 55. 35 plus 20 is 55, and that is equal to 55. That is a true statement, so we're good. Okay? So just using these equations to help us out. All right, the next one says this is an isosceles triangle. This isosceles triangle has two sides of equal length A. So you have this length of A and this length of A that are longer than the length of the base B. So A and A are longer than the length of base B. It says the perimeter of the triangle is 15.7 centimeters. The equation 2A plus 2B is equal to 15.7 models this information. Now, how they get that, the perimeter is the distance around an object, right? So if I wanted to write my perimeter, then I would take length A, add the other length A, and then add length B. So my perimeter in this case, given this triangle, would be 2A plus B. Okay, A plus A gives me 2A. All right, and we know that the perimeter is 15.7. So what I would do then is I would say, 2A plus B is equal to 15.7. Okay, now all I did was just, switch these around from one side of the equal sign to the other. You can do that. You can reorder them. Okay, you can switch them around. It doesn't matter. Okay, so it says if one of the longer sides is 6.3 centimeters, which equation can be used to find the length of the base? So I want to use this equation, okay? And if it says the longer side is 6.3 centimeters, okay, it tells us that A is longer than the base. So I know this. When it says the longer side is 6.3, that tells me that A is equal to 6.3. Okay? And then it wants us to actually find the length of the base, right? It wants us to find B. So what I want to do is I want to take 6.3 and I'm going to substitute that into this equation for A. So what I would get then is I would get 2 times A, but I don't want to write A. I'm going to write what A is equal to. I'm going to plug in 6.3. All right? Plus B is equal to 15.7. Okay? And so that question is asking us up here. Okay. 2 times 6.3, what is that, 12.6? So 12.6 plus B is equal to 15.7, and you subtract 12.6 from both sides. So then, what is it, 3.1? There we go. So B is equal to 3.1 centimeters. Okay? And that's what we got. So you do have to be able to substitute values in, and you do need to be able to solve equations. Okay? And that's something that we can practice. All right, this is one of those standard algebra problems where it says that, let's go ahead and read the equation, and it says that tickets to a movie theater cost $9 for adults and $6.75 for children. Ticket sales for one movie showing totaled $1,406.25. Okay. Now, I'm going to do something here. I'm going to kind of do this in a backwards thought process. I'm going to identify my variables first. Okay. What it wants us to know, we know how much the cost is. Okay, so we're given the cost for each ticket, but what we don't know is the number of tickets. Okay, that's the one thing we don't know here. You have the cost of the ticket, and then you have the number of tickets, and then you figure out how many tickets are sold, gives you the total amount. So I'm going to do this. I'm going to have the variable A, and I'm going to call that the number of adult tickets. You can use whatever variable you want, but A goes with adults, okay? So then I'm going to also create another variable, C, and that's equal to the number of child tickets. Okay? And I got C just because of the word child. So that's the thing, guys, is that, and what I want you to see is that, when I identify a variable, I'm thinking of a concept. I'm not just automatically assuming, A is going to equal some number. We don't know what that number is. So we have to give it a name. We have to say what exactly it is. And so in this case, it's going to be the number of adult tickets. C is going to be the number of child tickets. And this is something that we have to create, okay? And so I want you to write that we must create this. And it's important that we're able to do that, okay? Create variables and use them, okay? So now we want an equation that models the situation. So what I'm going to do is that I know that if I take $9 and I multiply that by the number of adult tickets, which is A, so 9 times A, if I add that to $6.75 times the number of child tickets, C, okay, then if I add those two numbers together, I'm going to get $1,406.25, okay? So again, I take $9 times the number of adult tickets, okay, that gives me a total amount. I take $6.75 times the number of child tickets, that gives me a total amount. I add those two numbers together and it gives me $1,406.25. Okay, so then it says, if 75 child tickets were sold, how many adult tickets were sold? So if I take this number and I say, all right, I'm going to plug in, I'm going to let C equal 75. So I'm going to get 9A plus $6.75 C, but I don't want to write C. I'm going to write what C is equal to. I'm going to write that we get 75, and then that's going to equal $1,406.25. Okay? So then, if I've got 9A, okay, let's do some math here. Someone tell me what 6.75 times 75 is. And you're going to get, so I'm going to drop this down, I'm going to get 9A plus 506.25, and that's equal to $1,406.25. Okay, so when I multiply these two numbers, I get this. All right, so now I'm going to subtract that from both sides. I'm running out of room here. Let me rewrite it over here.
That's 25, right?
506.25, yeah. So 9A plus 506.25 is equal to 1406.25. So then I'm going to subtract from both sides this 506.25 minus 506.25. And as a result, that's just going to give me 900, right? So 9A is equal to 900. Okay, divide by 9, and I'm just going to get that A is equal to 100. Okay, 100 what? 100 tickets, yeah, exactly. 100 tickets for adults, or adult tickets. Okay? So it is a little hard to write these equations, but it's not impossible. Okay? Identify your variables, write out an equation that you think is true, something that makes sense. Okay? And we'll work on it. Okay? But we just got to practice. Okay. All right, same thing here. Okay, I'm going to pause the video. I'm going to let you guys do this next question real quick. I'll read it out loud. Okay, Hugh bought some magazines that cost $3.95 each and some books that cost $8.95 each. He spent a total of $47.65. Let M represent the number of magazines and B represent the number of books. Which equation models this situation? Okay, you should have picked this one here. Okay, $3.95 times the number of magazines, and then $8.95 times the number of books is all going to give you $47.65. So if Hugh bought 3 magazines, how many books did he buy? So here's what we've got. All right, we know if Hugh bought 3 magazines, then we know that M is equal to 3. Okay, and we're going to plug that into this equation up here. So I'm going to do $3.95 times 3 magazines plus $8.95B, 8.95 times B, and that's going to equal $47.65. Okay. So now I've got 3 times 395. What does that give me, guys? Anybody know? That's going to give me $11.85 plus $8.95 times B, and that gives me $47.65. So if I subtract $11.85 from both sides, we're going to get, that's going to give me 35.8 is equal to $8.95 times B. Okay, if I divide both sides by $8.95, then these divide out, and we get that B is equal to, how many books did we get? Divided by 8.95? 4 books. So 4 books. Okay? It is kind of hard, but this question is almost the exact same thing as this one up here. Okay? Trick is coming up with the equation. All right? Okay. Let's go ahead and take a look at the next one. This next one's a little tricky. It says, Carlos is buying drinks to bring to a study group. The table shows some combinations of drinks he might buy. If Carlos buys 7 bottles of water, how many bottles of lemonade did he buy? So here's what we need to identify here. This table here gives us a lot of information. It says that we have the number of bottles of water X, and these numbers increase by 1. Okay? And then all of a sudden, and so we add 1 here, add 1, add 1. And then if we don't, over here it says the number of bottles of lemonade is your Y value. These values decrease by 1. Okay? So it says if Carlos buys 7 bottles of water, how many bottles of lemonade will he buy? So let's just continue this table. And I'm going to do X and Y. Okay? And my next number was 5. Okay, so I add 1 to 4. I'm going to subtract 1 from 9, and that's going to give me 8. Okay, if I have 6 bottles of water, then that means that I have 7 bottles of lemonade. Okay? If I have, say, 7 bottles of water, which is what we're looking for, then that means that I have 6 bottles of lemonade. Again, we still need to follow this process of adding 1, and here we would subtract 1 and subtract 1, okay? And that's our answer, okay? So if he buys 7 bottles of water, then he would have 6 bottles of lemonade, okay? All right. Now, in this one, it says Sophie is buying fabric to make items for a craft fair. Okay, the table shows some combinations of how much of each color fabric she might buy. Which equations model the total yards of fabric Sophie will buy? Check all that apply. So here's what we know. And let's kind of go ahead over here. Let me go back to this problem up here. What I noticed about this was that each of these numbers, if you add them together, give you what? Anybody notice? If you add 1 and 12, you get 13. If you add 2 and 11, you get 13. If you add 3 and 10, you get 13. So an equation we could have written here was x plus y is equal to 13. Okay? Now I'm going to look at the same problem here. Okay? She needs what I notice is if you take 1 and add it to 27, you get 28. If you take 2 and 26, that gives you 28. 3 and 25 also gives you 28, and so on. So what I know is an equation I can write is x plus y is equal to 28. Okay? So I automatically see that one here. Okay? Now the one thing that I can do is I could rewrite this. Okay, I don't have to always keep it in this form of x plus y equals some number. Okay, one thing I could do is I could take this equation and I could subtract y from both sides. Okay, which ends up giving me that x is equal to 28 minus y. Now, that correlates with this problem right here. Okay, even though it's switched, I could rearrange these and I could rewrite them and say 28 minus y is equal to x. Get the same thing. Doesn't really matter, okay? I could also take that equation here, x plus y equals 28, and I could subtract the x from both sides. And that leaves me with y is equal to 28 minus x. And that is seen right here. All right, and I could rewrite that as 28 minus x is equal to y. Okay, it doesn't really matter. All right, so we have these 3 as answers. Okay? Is that it for this page? For this page.